Today we will learn how to use mnemonic device theory to effectively make the best judgments on the relative strengths between two or more acids based on their stability of their conjugate bases. In acid-base chemistry, it is a good rule of thumb to keep in mind that the more stable an acid's conjugate base is, the more acidic the acid will be. Equilibrium will favor the side that has the acid whose conjugate base is more stable. The acronym theory works as a hierarchy, organizing each factor that affects the stability of the conjugate base in order of priority. The first is the letter S, which stands for size. It refers to the size of the atom to which the acidic proton is bonded to. The larger the atom, the longer and the weaker the bond it has with the acidic proton, meaning that the proton can be removed easily. This is the most important aspect of an acid's conjugate base when trying to determine its stability and therefore the strength of the acid. The example we'll use is comparing sulfur with oxygen. Because sulfur is much bigger atom, there is less orbital overlap and the bond is not as strong, and therefore it will be easier to remove. And always remember, size matters. The letter E refers to the electronegativity of the atom to which the acidic proton is bonded to. The more electronegative the atom, the better it is to stabilize the same negative charge. Since fluorine is more electronegative than nitrogen, it will be more willing to hold the negative charge and therefore have a more stable base. The letter R stands for resonance and refers to the fact that the conjugate base is more stable when it has resonance structures that will help delocalize the negative charge after the acidic proton leaves, and therefore make the conjugate base more stable. The more resonance structures in a conjugate base, the stronger the acid. In this case, the carboxylic ion is more stable because it has resonance and can more effectively stabilize the negative charge. The letter I stands for induction, or the process by which an electronegative atom that is not bonded to the acidic proton draws some of the negative charge and delocalizes the electron density, therefore slightly stabilizing the conjugate base. Since the chlorine can pull the negative charge better than the oxygen, it will have a more stable base. The final letter H stands for hybridization, and it is the weakest form of a conjugate base stabilization. A conjugate base becomes less reactive and therefore more stable as the atom that once was bonded to acidic proton obtains more S character in its hybridization. In other words, acidic groups that are sp hybridized are more acidic than groups that are sp2 or sp3 hybridized. This is observed because having more S character means having lone pairs in low energy orbitals, making it harder for lone pairs to leave in and therefore less reactive and more stable sp hybridized conjugate bases. Thank you for watching, and don't forget to hit that like button and subscribe. Bye!